Hello everyone. Today we will be learning about what is pervaporation. So, what is pervaporation? Pervaporation is the separation of liquid mixtures by partial vaporization through a membrane. This term is derived from the two steps of this process, where the liquid mixture first permeates through the membrane and then evaporates into the vapor phase. So, how does pervaporation works? The membrane works as a selective barrier between the two phases, the liquid phase feed and the vapor phase permeate. Vaporization allows the components of the liquid feed to transfer through it. The difference in the rate of transport of individual components through the membrane will determine the separation of the components. Mass transfer through a membrane can be divided into three major steps. First one, scorption, which is the absorption, and adsorption, which is considered as a single process. This permeates the component of the feed side into the membrane. Secondly, the transport of components across the membrane by diffusion according to Fick's law. Third, the desorption at the permeate site into the vapor phase under vacuum. There are two main characteristics of the membrane. Firstly, selectivity. Selectivity is the quality of carefully choosing something as the best or most suitable, also called as separation characteristic. Secondly, the permeate flux across the membrane. The membrane permeation flux is defined as the volume flowing through the membrane per unit area per unit time. So, what is the advantages of evaporation? A high product purity is obtained and there are no environmental pollution. Mixtures with small differences in boiling points can be separated effectively and economically. The feed mixtures to be treated may be supplied in either liquid or vapor form. Low energy consumption for pervaporation and vapor permeation process. Evaporation significantly reduces the energy consumption for hybrid systems. Due to the modular design, even small units can operate economically. High degrees of flexibility regarding the feed mixtures may be accommodated to final product qualities. However, with all those advantages, evaporation does come with its disadvantages. Firstly, the separation depends on the characteristics of the feed pressure, the sensitivity to friction loss and possibility of condensation, the formation of stagnant condensate films which partially covers the membrane on the feed side. There are also boundary conditions for evaporation. There are four of them, mainly the removal of water from organics, removal of organics from water, separation of organic mixtures, and the concentration of aqueous solution. Evaporation is a practical and financially viable alternative for distillation, especially when draining solvents, particularly when azeotropes must be degraded or liquids with similar boiling points must be separated. In such cases, a hybrid process is normally the most economically viable. Hydrophilic evaporation or vapor permeation can also be used to remove water from a reaction mix and thus favorably alter the reaction balance. To remove volatile organic substances from wastewater, evaporation is competitive with active carbon adsorption and stripping. Throughout the world, there are various large-scale implementations, with the majority addressing drainage of alcohol. The capacity of most installations lies between 50 and 300 liters per day. Thus, these are rather small installations. Here are a few examples of sectors which evaporation can be implemented. The chemical industry, the pharmaceutical industry, the petrochemical sector, refineries, tank and drum cleaning, and paint, gloss, varnish, or printing ink production. Pervaporation does have its industrial usage, mainly water distillation factory that uses pervaporation, Petrocep, which is a world leader in providing sophisticated and innovative membrane distillation, as well as pervaporation membrane systems. Pervaporation and vapor permeation. Clean technologies are used to recover spent or toxic solvents, which is reused instead of incinerated as hazardous waste. With that, I hope that all of you have learned something new on pervaporation. Thank you very much.